In this lesson, we want to talk about the law of sines, and specifically here we'll look at the easier case where we have angle side angle, and then also if we have the side angle angle. Okay, so before we jump in and look at problems, I want to talk a little bit about where the law of sines comes from. And so if you're not really interested in how this guy gets derived, you can just skip ahead to the examples. So the first thing is when we talk about solving triangles, earlier in the course we solved right triangles with the SOHCAHTOA, right? This just means we're finding all the missing sides and all the missing angles. Now, when we work with an oblique triangle, this is a non-right triangle, then basically we have to use something like the law of sines or the law of cosines because we don't have a right triangle, okay? So basically what I'm going to do is I'm going to start off with this acute triangle, okay, which let's just go ahead and call it ABC, okay? And I want to just draw your attention to a few things in terms of the naming conventions. So you see that you have capital letter A, capital letter B, and capital letter C. Those are your angles, okay? And then when you look at the lowercase letters, those are the sides, okay, that are across from their corresponding capital letter angle, right? So what do I mean by that? In other words, this is angle A. If I go across, I have lowercase a. This is for the length of this side here, okay? That's all that is. If you look at B here, this angle right here, if I go across, this is B, right? So it's the length of this side here, right? So on and so forth. You can do C as well. This is angle C. If I go across, okay, here's lowercase c here, so it's the length of this side. So you just need to understand how this is named because pretty much in every book, this is how they're going to do it. Now, what I'm going to do, because we have an oblique triangle, we're going to split this triangle ABC up into two different right triangles, okay? So you see I have this perpendicular here that's been drawn, and we've labeled this as H for the height, okay? You've seen this in geometry where you basically have the height so you can get the area, okay? So basically what we would do here is think about these two separate triangles. So I'm going to say I have triangle, and I'll call the first one ADB, so ADB. Okay, so if I think about that, that's A, D, B like this. So that's a right triangle now. And then I also have another triangle that I'm going to form inside. So let's call this triangle, okay? And let's go ahead and say this one's BDC. So let's say B, D, C. So B, D, C like this, okay? So you see the two right triangles. Now, let's think about, let's say, the sine of this angle here to start. So what is the sine of this angle A? Well, basically, I'm going to think about the opposite here, which in this case is H, right? If I'm thinking about this right triangle. So H over, what's the hypotenuse? Well, in this case, it's going to be C, right? Again, you might have to highlight this to really see. So this is ADB like this. If you think about this right triangle, this is your opposite and this is your hypotenuse. So this is H over C, okay? If you use a similar thought process, if you looked at C, okay, this angle here, what is the sine of this C guy? Well, now it's going to be the opposite, which is H, over the hypotenuse, which is A here, okay? So let's grab these two results, and let's just write this over here. So I have the sine of this angle A here was H over C, and then I also have the sine of this angle C is H over A, okay? What you're going to do is you're going to solve each one for H. So in other words, I would multiply this side by C and this side by C. And over here, let me make sure this is lowercase so I don't confuse anybody. Over here, this is going to be A and this is going to be A. So you multiply both sides here by A, multiply both sides here by C. What's going to happen is this over here is going to cancel, okay? And this over here is going to cancel. So really, I can just erase this and say that H here is equal to C times the sine of A, and H here is equal to A times the sine of C. So since each one is set equal to H, I can set them equal to each other legally. So I can just erase this, and I can just drag this up here, or actually I'll put this over here to match the convention in the book. So let me write this a little bit bigger. So A times the sine of C, okay, is equal to, you're going to have C times the sine of A, like this. Okay, so what I want to do now is just divide both sides by the sine of A times the sine of C. So I'm going to divide this side by the sine of A times the sine of C, okay? And this side by the sine of A times the sine of C. So from here, I'm going to cancel this with this, and I'm also going to cancel this with this. And so what I get is, I get this A over the sine of A. Let me make that better. So let me make that better. So sine of A like this is equal to the C, okay, the lowercase c, is over the sine of C, okay, like this. So what this is telling you is that basically the lengths of the sides in a triangle are proportional to the sines of the measures of the angles opposite them. We could also do a similar process to show that A over the sine of A, okay, is equal to B over the sine of B. So I could say A over the sine, let me make this better. I'm trying to write this as small as I can. So sine of A is equal to B over the sine of B. And you could also show that B over the sine of B is equal to C over the sine of C. So I could also put C over the sine of C, okay? So you can go through and prove that to yourself if you want to go back to the triangle. But this is basically what we're going to be using throughout this lesson. It's very, very easy, okay, overall. You're just going to use one part. So in other words, you'll either use this guy right here, or you'll use this guy right here, or you'll use the original one we had, which is A over the sine of A is equal to C over the sine of C. Okay, so let's go ahead and jump in and look at an example. So we're given that B, which again, if you get a capital letter, this is an angle, is equal to 46 degrees, C is equal to 69 degrees, and A is 34 centimeters. So I'm going to tell you, like most people will, when you start these problems, just make sure you draw a little sketch. It doesn't matter if it's accurate at all. You just want something to put numbers down. All right, so I've already pre-drawn this little sketch for us. So you see that your angle B here is 46 degrees. Your angle C here is 69 degrees. And then this guy, if you go opposite of A, this is your A here, it's 34 centimeters, okay? So now if I think about what I need to find the measure of angle A. So let's go ahead and do that first. Remember, your triangle sum property tells you that the angles inside of a triangle are going to sum to 180 degrees. So on a calculator, you could go 180 degrees minus 69 degrees minus 46 degrees, and this is going to give you 65 degrees, okay? So you can go ahead and put a 65 degrees in there like that, okay? So that's what A is going to be equal to. Some teachers want you to draw this out, and some will say, okay, I want your answer, so we'll say A is equal to 65 degrees here like that. So we'll do both, okay? In terms of B, how are we going to figure this out? Well, you've got to work with what you have. So in other words, I have an angle measure A, and I have lowercase a, the side length, okay? So I can say that A over the sine of A is equal to B over the sine of B, okay? So I can just plug in for A here. This is 34 centimeters. So this is 34 centimeters. And then for the sine of A, you're taking the sine of 65 degrees. So the sine of 65 degrees. Then for this guy right here, B over the sine of B, well, B, the capital letter B is 46 degrees. So we're going to put 46 degrees there. And basically, if you want to solve this guy for B, right, lowercase b, you would say that lowercase b is equal to, you're just going to multiply both sides by the sine of 46 degrees. So you would say 34 centimeters times the sine of 46 degrees over the sine of 65 degrees. Now, if I punch that up on my calculator, I get about 26.9859, okay? Let's just go ahead and round this to the nearest tenth, okay? So I'm going to say that would be about 27. So let's just approximate this. I'm just going to erase all this. And I'm going to use the approximately symbol, okay? So I'm going to put approximately 27, okay? And this should be in terms of centimeters. So let's put this up here. So B is approximately 27 centimeters. And in terms of where you need to round, just get with your teacher or your assignment. It should tell you. Now, for C, the mistake that a lot of people make is they use this rounded value. You want to stick with the information you're given. You're given a hard-coded value here of 34 centimeters. Just use that again. So I'm going to want to do, and let me do this on another page. I'll do A, which is 34 centimeters, over the sine, okay, of A. Let me make that better. So the sine of A, which was, again, it's 65 degrees, is equal to, you're going to have lowercase c over the sine of, what was our angle C? That was 69 degrees, okay? So again, very easy to do overall. You're just going to multiply both sides by sine of 69 degrees. So you're going to have 34 centimeters times the sine of 69 degrees, okay, over the sine of 65 degrees. Okay, so this is what C is going to be. So let's erase this. So this would give me about 35.023, let's say 1. Again, if you want to go to the nearest tenth, we'll just say 35. So let's just erase this. We don't need it anymore. And we'll go back up and we'll say that this is about 35, okay, centimeters. So you can put this here. C is about 35 centimeters. So just depending on what your teacher asks for, you might want to list things like this. You might be asked to draw a triangle and then fill in the missing parts. Whatever it is, just make sure you have all the missing sides. Okay, here we got B is about 27 centimeters, C is about 35 centimeters, and then your missing angle, which here is 65 degrees. Okay, let's look at another one. Again, these are very, very easy. So A here is 52 degrees, B here is 67 degrees, and A, lowercase a, is 18 centimeters. So let's go down. And so again, A is 52 degrees, B is 67 degrees, and basically C is unknown, but again, we can find that really quickly. Just go ahead and do 180 degrees minus 52 degrees minus 67 degrees, and that's going to give you 61 degrees. Okay, so let's put that in there. So this is 61 degrees. And again, you might want to list this up here. So let's say C is equal to 61 degrees. And then we want to find B and C here, okay? So I have my angle measure 52 degrees here for angle A, and then side A is 18 centimeters. So again, I can just set this up. I can say 18 centimeters over the sine of this angle A, which is 52 degrees, is equal to, let's just go ahead and start with B. So I'll say B over the sine of 67 degrees, okay? And if you haven't noticed, basically this guy right here always ends up being multiplied by this. So a shorter way to do this would be B is equal to, basically the sine of whatever this angle is times this ratio here, okay? That's all you need to do. So let's go ahead and say B is equal to 18 centimeters times the sine of 67 degrees over the sine of 52 degrees. Let me just erase this. So I get about 21.026, let's say 5, okay? And let's round this to the nearest tenth. So that's going to give us about 21. So let me erase this, and I'll say that this is about approximately 21. And don't forget your units, so we'll say centimeters. And again, I'll answer over here. So B is approximately 21 centimeters. Okay, for C, let's use a little shortcut. Okay, let's go ahead and say that C is equal to, again, I want this guy right here, 18 centimeters, okay, over this angle here, the sine of this guy, so the sine of 52 degrees. But I'm multiplying this by, again, remember you would have had C over the sine of C, which is the sine of 61 degrees, but we multiply both sides by that guy, okay, so we can clear it. So this is times the sine of this angle here, which is 61 degrees. Okay, no need to do two steps when you can do it in one. So if we go ahead and crank this out, you're going to get about 19.9784. Let's go ahead and round this to the nearest tenth. Let's just say it's about 20. Okay, so 20 centimeters. So let's erase this, and I'll say lowercase c here is approximately 20 centimeters. And again, you can write it in here if you want to, so 20 centimeters, okay? So we found C is about 20 centimeters, B is about 21 centimeters, and angle C here is 61 degrees. Let's just look at one more. So we have A is equal to 83 degrees, C is equal to 53 degrees, and lowercase c here, the side length is 8 yards. Again, we have our lowercase a, this side here we need to solve for, lowercase b, this side we need to solve for, and we don't know the measure of this angle B. I always start with the measure of the angle because it's the easiest. So you want 180 degrees minus 83 degrees minus 53 degrees, and that gives me what? Well, I would get 44 degrees. Okay, so this is 44 degrees. So let's erase this. Let's put B is equal to 44 degrees. Okay, so in this particular case, let's just go ahead and set up both of them really quickly. So we know we need to find this guy right here. So I'm going to use what's given here. I have this side C here, which is 8 yards, and I have the angle measure C, which is 53 degrees. So in each case, I'm going to use this ratio where I say 8 yards, okay, over, let's go ahead and say the sine of 53 degrees, okay. So if I wanted A, so A would be equal to what? It would be this times the sine of this angle here, okay. So the sine of this 83 degrees. Okay, so you set that one up. And then for B, B would be equal to, again, I'm going to keep this part the same, so 8 yards over the sine of 53 degrees. Let me make this better. So sine of 53 degrees, and then times the sine now of, in this case, the angle B is going to be 44 degrees. Okay, so 44 degrees there. All right, so let's start with A. Let's punch that up on our calculator. So if I round this to the nearest tenth, I'll just go ahead and say it's about 9.9. So 9.9, and this is yards. So I'll say approximately. Let's answer it twice. So here I'll put approximately 9.9 yards, and I'll do it up here as well. So A is approximately 9.9 yards. And then for this one, let's just go ahead and say that's about 7, right? Again, rounding to the nearest tenth, so it's about 7. So let me get rid of this, and I'll say this is approximately 7 yards. And then up here, B is approximately 7 yards, okay? So again, we found that A is about 9.9 yards, B is about 7 yards, and then this missing angle measure of capital letter B here is 44 degrees. Okay, so another thing you're going to see in this section is about the area of a triangle. So this is going to involve side, angle, side. So you're going to have two sides, okay, and the angle between them. So the method used to derive the law of sines can also be used to derive a little formula to find the area of a triangle. So I want you to recall from basic geometry, the area is equal to 1/2 times the base times the height, okay? So here our base would be this lowercase b, right? Because that's this side here, right? And then our height would be this h here, okay? This guy right here. So basically, I want you to think about our right triangle ADB again. Again, if we did sine of A, so sine of A, this is equal to, again, h over c. So h over c. Now, if I solve this for h, I'm going to get what? I'm going to get sine of A times c is equal to h. So sine of A times c is equal to h. So I'm going to plug this in right here into this formula, okay? So I'm plugging this in right there. So what I'm going to get is that the area is equal to 1/2 times the base times, instead of h, I'm going to have basically c times the sine of A. So let's erase this and put c times the sine of A, okay? Now, similarly, you could go through and calculate other formulas, okay, using a similar thought process. So you could say the area is equal to 1/2 times this. Now let's go A times B, okay, then times the sine of C. And then lastly, let's go area is equal to 1/2 times, let's see, what didn't we use? So it's going to be A times C and then times the sine of B, okay? So notice that this capital letter that's involved, okay, this angle, is always the one that's not involved here. I know these are lowercase, but if you look, you have lowercase b and lowercase c. This is uppercase A. Lowercase a, lowercase b, uppercase c. Lowercase a, lowercase c, uppercase b, okay? And that's because if you look at the way this is set up, if you have side B and side C, so this is side B, and this is side C, so where's the angle between them? Well, that's going to be this guy right here. It's going to be A, right? If I looked at A and B, so those sides, so this is side A, and this is side B, okay, what's the angle between them? It's going to be C. If I look at the last one, which is A and C, so if I look at A and I look at C, what's the angle between them? It's going to be B, okay? So this is a little formula you can use, okay, because in some cases, you're not going to know the height. You're not going to know what H is, okay? So you can basically use this instead. All right, let's look at this example here. So B here is 5 kilometers, A here is 10 kilometers, and C here is 121 degrees, okay? So again, you sketch yourself a little diagram, and basically we have, again, the side B here is going to be 5 kilometers. If I look at the side A here, it's 10 kilometers, and we know that C is 121 degrees. So again, you have this side here, you have this angle, you have this side here. Again, notice that the angle is between them, okay? It's very important. So how do we do this? Well, again, we'll say the area is equal to, I'm going to go 1/2 times, again, you take these sides, so 5 kilometers, times, you're going to go 10 kilometers, so 10 kilometers, and then times, this is going to run off the screen, so let me drag this over a little bit. So then times the sine of the angle between them, so the sine of 121 degrees, okay? And so let's just go ahead and crank this out, and actually, since it doesn't fit on the screen very well, let me kind of simplify this here. So 5 times 10 is 50. 50 divided by 2 is 25. Kilometers times kilometers is going to be kilometers squared. So let me get rid of all of this and say that the area is going to be 25 kilometers squared, okay? And then basically times the sine of 121 degrees. So let's just go ahead and punch this up into our calculator. Just do 25 times the sine of 121 degrees. And I'll go ahead and say that's about 21.4. Again, if you're rounding to the nearest tenth. So the area is about, okay, approximately 21.4. And it's going to be kilometers. Again, this is squared. Very important that you square your units there because, again, you end up multiplying the kilometers times the kilometers, so you get kilometers squared. Okay, let me throw a wrench at you. So this is kind of a harder problem, a harder variation of this problem. So you have A is 11 feet, C is 69 degrees, and B is 76 degrees. So you've seen the pattern before with side, angle, side, right, where the angle is between them. But this one you have two angles and a side. So if I go down to my little sketch here, you see you have these two angles in this side here, okay? So basically to solve this guy, to find the area, I either need to figure out C or I need to figure out B. Okay, it doesn't matter which one you do, you're going to get the same answer. But basically if you had C, you have a side, an angle, and a side. If you had B, you'd have a side, an angle, and a side. So let's just go ahead and do B, okay? So we're given this 11 feet here. So to use the law of sines, I've got to first work with A, find the angle measure here. So that's going to be 180 degrees minus 69 degrees minus 76 degrees, which is what? Well, that's going to be 35 degrees. Okay, so this right here is going to be 35 degrees. So let's erase this, okay? So now again, if I'm trying to find this guy right here, I say that basically A, which is 11 feet, over the sine, okay, of A, in this case is 35 degrees, so the sine of 35 degrees is equal to, you'll have this lowercase b, again, it would be over the sine of 76 degrees, but we know we're just going to multiply this by this sine of this angle measure here, which is 76 degrees, okay? So basically, I'd have the sine of 76 degrees times 11 feet over the sine of 35 degrees. So that would be about 18.6, okay? So let me erase all of this, and I'm just going to say, and I'll just put this up here, that this guy right here is about 18.6, and this is in terms of feet. So now it's really easy to go back to our problem. We're going to say that the area, okay, is going to be equal to 1/2 times, again, I'm taking this guy right here, which is the 18.6, okay, feet, and then times this guy right here, which is the 11 feet, okay, and then times the sine of the angle, okay, between them. So in this case, it's 69 degrees. So times, let me do this down here, the sine of 69 degrees, okay? So let's just punch this into a calculator. So if I round this to the nearest tenth, I'm going to say this is about 95.5 feet squared, okay, or square feet. However you want to say that. So let's go ahead and say this is about 95.5 feet squared, or again, square feet, however you want to put that. In this lesson, we want to talk about the law of sines, where we have the ambiguous case. What's given is the SSA, or the side-side angle. All right, so in the last lesson, we talked about how to basically solve these oblique triangles. These are non-right triangles when you're given two angles and one side. So this could be angle side angle, which is ASA, or it could be side angle angle, right, SAA. Now, that's the easy case. You just go immediately into using the law of sines. Okay, you can just basically set up these proportions and you can solve for what you need to solve for. When you get to the ambiguous case, you're going to see side-side angle, and now you have to dig into the details of the problem. So before I get started into that, I just want to recap some things that we're going to need for this lesson. Some of you might find this quite boring, so you can just skip ahead to the examples, but I think you might find it quite beneficial. Okay, so first and foremost, let's revisit the law of sines. We have this A over sine of A is equal to B over sine of B, which is equal to C over sine of C. So we just write this in a compact form. You're only going to use two of these at once, right? So you might set these two equal to each other like this, okay? If you're trying to solve for something in there, or you might set these two equal to each other, or you might set this one and this one equal to each other, whatever you need to do, okay? So you're basically only going to use two at one time. Now, alternatively, you could also write this like this. So you could say the sine of A over A is equal to the sine of B over B, which is equal to the sine of C over C. Now, really quickly, because I know somebody's going to be confused, remember we name the triangles, okay? Generally speaking, you'll see triangle ABC in your textbook. So capital letter A, capital letter B, capital letter C. Remember, those are angles, okay? The lowercase counterparts, in other words, if I think about capital letter A and lowercase a, the relationship is basically the lowercase letter is going to be opposite of the angle, okay, that's named with that capital letter. So you have capital letter A. If I look at lowercase a, that's going to be the side opposite of that angle, okay? It's going to be the length of that. If I look at lowercase b, it's going to be the side opposite of this angle, okay, with capital letter B. That's the name of it. Then if I look at lowercase c, it's going to be the side opposite of this angle named with an uppercase C or a capitalized C, however you want to say that. Now let's think about some of the properties for an angle, let's call it beta, of a triangle. Okay, so this is really important. When you think about the sum of the angles in a triangle, we know it's 180 degrees, okay? We know we can't have an angle in there that's going to be 0 degrees. It's going to be not possible. And also, we can't have an angle that's 180 degrees. That's not possible as well. So we know that the sine of beta has to be greater than 0. Can't be 0 because, again, you can't have a 0-degree angle, okay? And you also can't have an angle that's 180 degrees. If we go back to the unit circle, remember, if you think about a sine value of 0, it's going to happen basically if your angle is 0 degrees or if it's 180 degrees, and I just said that's not possible, okay? So if we go back, we think about the next part of this, the sine of beta is, again, greater than 0 and less than or equal to 1. Well, remember, when you think about the sine, okay, we know the range of sine in general is from -1 to 1, but again, if you're working between 0 and 180 degrees, not including 0 or 180, well, then basically you're going to be between 0 and 1, where 0 is not included and 1 is, right? If you have a 90-degree angle, well, you can have a sine value of 1, okay? That means you have a right triangle. So let's go back. Here I said sine of beta equals 1. If this is the case, then beta is 90 degrees. Again, you have a right triangle. Lastly, we need to understand this because when we have two solutions here, this is going to come in. So remember the concept of a reference angle. If you have sine of some angle beta, let's call it 30 degrees. So sine of 30 degrees. This is equal to sine of 180 degrees minus 30 degrees, okay? 30 degrees here, if I take that away from 180 degrees, this would be 150 degrees. So this is sine of 150 degrees. We know this is true because of the concept of a reference angle. If you go back and you think about this, let me erase this highlighting here. If I had a 30-degree angle, the sine value is a half. If I had a 150-degree angle, okay, and I didn't draw that really well, so let me try that one more time. The reference angle there is 30 degrees, so the sine value is also a half, okay? Again, this is going to come up in a moment because we're basically going to be using the inverse to find our missing angle measure, and it might be possible that we have one that's, let's say, 30 degrees and another that's 150 degrees, okay? So we need to keep that in mind. Now, just a few other quick things about triangles that you may or may not know. Assuming the triangle has sides that are all of different lengths, the smallest angle is going to be opposite the shortest side. Let me highlight that. The smallest angle is opposite the shortest side. The middle valued angle is opposite the intermediate side. The largest angle is opposite the largest side. Okay, so you need to make sure you understand that because, again, it's going to come up today. All right, let's jump in now and look at some examples. I'm going to go through all the different scenarios and give you an example of each. So the first thing we're going to look at would be where there's no such triangle and you're given an acute angle. So we're given some acute angle A, and remember, opposite of A, we're going to have this side here, which is named with lowercase a. So we're given some angle A, and then opposite of that, we have some side A. These are both going to be given to us. We're also beginning given this side B here, okay? So the first thing you can think about, if you wanted to show that there was no such triangle, you could say that H is going to be greater than A, and it's going to be less than B, okay? So you could prove it this way. You could also show that the sine, okay, of this guy B, if you try to set this up with the law of sines, you're going to end up with something that's greater than 1. Okay, so I'll show you both for this example that's coming up in a minute. Now, you might be thinking, how in the world am I going to get H? So let's talk about that real quick. Let's get rid of this, okay? And let's think about if we formed a right triangle here, okay, and we thought about this angle A, well, the sine of A is equal to what? It's the opposite over the hypotenuse. So in this case, because I formed a right triangle here, the opposite of it is H, and then the hypotenuse is B, okay? If you wanted to solve this for H, you would say that H is equal to B, okay, whatever this side is here, times the sine of A, the angle that you're given, okay? This is pretty easy to remember. Just going to erase this real quick and just drag this up here. Let me go down and we'll read off our problem, and we'll come back and we'll just kind of use this as a visualization of it. So we're given here that A is 61 degrees. So notice this is an acute angle, right? Then B is equal to 29 centimeters, and A is equal to 20 centimeters. So again, this is your angle here, and then this right here, because it's the lowercase letter counterpart, this is the side that's opposite of that, okay? So when we set this up, we'll say this is 61 degrees, okay? That's the angle you're given. Opposite of that, you have this side. Let's just go ahead and say, again, it's A, so this is 20 centimeters. And then B, we're told this is 29 centimeters. So again, one way you can prove that there's no such triangle, you can basically plug into this guy right here, and you could say, okay, is H falling into this category? Is it greater than A and less than B? If it is, you can stop and say no such triangle, okay? So basically, I'm going to have B here, which is going to be 29 centimeters, so H is equal to 29 centimeters, times the sine of A, so the sine of 61 degrees. So this is going to be an approximation. So h is about, or approximately, we'll say 25.4 centimeters, okay? So you can see here that if I set up this inequality, I could say that 20 centimeters, which is A, is less than 25.4 centimeters, okay, which is h, is less than, you could say 29 centimeters, which is your value for B, okay? So we fall into this case here where we could say there's no such triangle, okay? It's not possible. The other thing you can do, and let me just erase this, if you wanted to do it this way, you could say basically that the sine, okay, the sine of this angle here, 61 degrees, okay, so the sine of A over A itself, in this case is going to be 20 centimeters, is equal to, again, the sine of this angle B over this B measure here, which is going to be 29 centimeters. Now you can multiply both sides by 29 centimeters. Let me just kind of slide this down a little bit. So we'll say times 29 centimeters over here. So we'll say this is equal to the sine of B. So the sine of B is approximately, let's just go ahead and say it's about 1.3 in terms of this guy. And again, the sine value is not going to be greater than 1. So that's another way you can prove that there's no such triangle. So however you want to do it, basically if you're going through the process of trying to solve the triangle and you get something that doesn't make any sense, it's just nonsense, you want to stop and say no such triangle, okay? So let me just put this over here and just say no such triangle. All right, let's look at another scenario. This is one where we end up having a right triangle. So basically here, you're going to see that this A value here is exactly equal to H, okay? So if A is equal to H, and then you could also say either A or H because they're equal, let's just go ahead and say A is going to be less than B, then we know that we have a right triangle. Now another thing here, since you notice you have B as a right angle, you could say that the sine of B, remember this is going to be equal to 1. So two ways to kind of check this. Let's go ahead and look at our example real quick. So we have A is 30 degrees, C is equal to 2 times square root of 5 inches, and A is equal to the square root of 5 inches. Now, instead of giving you a letter B, I gave you a letter C, just to throw a wrench at you. This is not any harder. If you want to work with this on this particular image, you just need to cross this out. Let me use a lighter color. You need to cross this out and put capital letter B, cross this out and put capital letter C, cross this out and put lowercase c, cross this out and put lowercase b, okay? Just adjust for what you're given. They're not always going to give you things in the exact format it is in your book, okay? So the first thing is, I want to prove that A is equal to H. How do I do that? Well, I'm given that A is equal to the square root of 5 inches. I'm given that, and I messed that up, I'm given that C is equal to 2 times the square root of 5 inches, okay? And I'm given that this angle A is 30 degrees. Now remember, for the height, we can say the sine of the angle A, is equal to, again, it's the opposite, which you could use as H here, okay, over the hypotenuse, which in this case we're going to use C, okay? So basically H is going to be C times the sine of A. So H, you can write this over here, H is going to be C, which we know is 2 times square root of 5, 2 times square root of 5 inches, times the sine of, in this case, it's 30 degrees, right? The sine of A. So what is the sine of 30 degrees? We all know from the unit circle it's a half. So let me put a little border here. H is going to be equal to 2 times the square root of 5 inches times 1/2, okay? My writing's getting a little sloppy here, so let me change that and put inches there. So we know, or actually I can move this out to the end so that we don't have to mess with it for right now. We see this 2, we cancel with this 2. And basically, H is equal to the square root of 5 inches. Well, what is A? Square root of 5 inches. So you've already shown that A is equal to H, and also you can see that A is less than B. In this case, we swapped B and C around. So again, you got to keep that straight in your mind. So this value here, okay, is less than this value over here. That's all you need to worry about. Now, in this particular case, you could also show that the sine of this angle, in this case it would be the angle C now, is equal to 1. So let's go down and think about this. So again, you use your law of sines. You could say that the sine of 30 degrees over this square root of 5 is equal to, you would have your sine of C over, you would have 2 times square root of 5, okay? So let's just go ahead and say this is a half. So I have 1/2, and then I'm dividing by square root of 5. So I'll just say down here it's 2 times square root of 5. Okay, so 1 over 2 times square root of 5, like this, is equal to, I'm going to multiply both sides by this. So I'm going to multiply both sides by 2 times square root of 5. And so look, this is going to cancel here with here, and this is going to be equal to the sine of C. So the sine of C is equal to 1. okay? So a little rough sketch of this if you want to look at it. Basically, if you want to find the rest of this, so you already know that C is a right angle, right? The sine of that guy is 1. We already know that opposite of that, where we're given that this is 2 times square root of 5 inches. We know A is 30 degrees, opposite of that, square root of 5 inches. So we need to find this and this. So where does that come from? If I want to find this 60 degrees here, the measure of angle B, again, what I want to do, if I come back up here, let me erase this. I would say that B is equal to 180 degrees minus 30 degrees minus 90 degrees, which is going to be 60 degrees, right? Remember, the 3 angles in a triangle have to sum to 180 degrees. So I can just take 180 degrees minus the measure of one angle minus the measure of the other angle. That gives me the measure of the remaining angle, right? Which in this case is B. So B here is equal to 60 degrees. Now, how do I find this lowercase b? How do I find this guy right here? And let me write in here that C is 90 degrees so we can solve this completely. Well, lowercase b is going to be found using, again, the law of sines. So I'm just going to go, in this case, I'll go square root of 5 inches over, I'll go the sine of 30 degrees. So I just did A over the sine of A is equal to, I'm going to say B, okay, B, which is unknown, over the sine of B. So the sine of 60 degrees. So the sine of 60 degrees. We know the sine of 60 degrees is square root of 3 over 2, right? So let me put this in here as square root of 3 over 2. And we know the sine of 30 degrees is a half, okay? So this is a half. Okay, so let's think about simplifying this a little bit. We know this would basically be 2 times the square root of 5 inches, okay, if I simplify that. So this would be 2 times the square root of 5 inches. Over here, this would be 2b over the square root of 3. So what I'm going to do, to get b by itself, I'm going to multiply both sides by the square root of 3 over 2. So this will cancel, and this will cancel, okay? And over here, square root of 3 over 2. So this is going to cancel. And basically, you get that b is equal to square root of 3 times square root of 5 inches, which I could write as a square root of 15 inches, right? So basically, b is the square root of 15, okay, inches. So let me erase this. And so now we've solved the triangle, right? We know all the sides and all the angles. Again, if you go back to this little picture here, or this little image, whatever you call it, again, this is 60 degrees, that's for b. And then the side opposite is square root of 15 inches. All right, let's look at another scenario. So this will be our third scenario. So here, you're going to see that basically your A is going to be greater than or equal to your B, and you're going to have exactly one triangle, okay? So you can also say that 0 is going to be less than your sine of this angle here, B, okay, which is going to be less than 1, okay? It can't be equal to 1 because you don't have a right triangle in this particular case. Okay, so let's go ahead and look at an example. And so we have C is equal to 39 degrees, B is equal to 28 inches, and C is equal to 30 inches. Now, again, I switched the letters around on you. Don't freak out. So this is your angle that you're given. This side here, lowercase c, is the one opposite of that, okay? So you just plug back into the diagram that you're looking at. But for this one, you really don't need it. If you notice that this guy right here, okay, this right here is 30 inches. It's opposite of the angle you're given. If this measurement here, which is 30 inches, is greater than or equal to this measurement here, you know you're in the scenario where you're going to have exactly one solution. You can just start pounding away at it, okay? You don't need to do anything else. So the first thing I'm going to do is I'm going to solve for my angle B. So let's start with that. So I'm going to say that the sine of B over B, okay, is equal to the sine of C over C, okay? And we know we can multiply both sides by B here, okay? So you can just get rid of this, and then I can just plug in. What is C? It's 39 degrees. Let me change my color here. So this is 39 degrees. What is lowercase c here? It's 30 inches. So this is 30 inches, okay? And then what is B here? It's going to be 28 inches, okay? If you want to cancel the units visibly, you can. So this is going to cancel. So basically, let me make this a little bit better. Okay, so this is 30 right there. Basically, you punch this into a calculator and you're getting an approximation. So you say sine of B is approximately, I'll say 0.5874. So 0.5874. And I'm using more decimal places here because I'm going to take the inverse, okay? So to find B here, you want to take the inverse of this guy, okay? So you could wrap this entire thing in parentheses here. So this entire thing here, plug it into the calculator, go sine inverse of that. Or you can do this way. You're going to be close enough. So I'll go ahead and say sine inverse of this guy right here, 0.5874, is going to be approximately, we round it to the nearest tenth, let's just say it's 36 degrees. So let's go ahead and say this is 36 degrees. And again, this is going to be my B here, okay? So let me erase all of this. And I will go ahead and say that B is going to be 36 degrees, okay? And this is approximately, so let me make the approximately symbol here. So then what is A? I'm solving for A here. Again, this is pretty easy. I'm going to do 180 degrees minus 39 degrees minus 36 degrees. This is going to give me what? So 180 minus 39 is 141. Take away 36, you get 105. Again, this is an approximation, okay? It's not going to be exact. So let's say this is approximately 105 degrees. And if I want the lowercase a here, again, I could just use the law of sines again. So again, go with what you know. So I'm going to go that 30 inches, which is this lowercase c, over the sine of 39 degrees. So the sine of 39 degrees, again, the sine of c, let me make that better. I'll say is equal to, you're going to have your lowercase a over your sine of 105 degrees. Again, I'm going to multiply both sides by the sine of 105 degrees, so I might as well just do it over here. So the sine of 105 degrees. So again, remember this is an approximation, so you can show that here if you want to, and say this is approximately A. Okay, most teachers will allow you to put equals there as well. And I'll go ahead and say this is about 46 inches. So let's say it's about 46 inches, okay? Now let me show you this sketch really quickly, and then I'm going to come back and show you why there can't be two solutions, okay, how you could prove this. So let me show you the sketch I made. So here you have your angle A, which is 105 degrees. Opposite of that, you have your side A, which is 46 inches. Again, this is an approximation. For B, it's 36 degrees. Opposite of that, okay, over here, you got 28 inches. And then C is 39 degrees. Opposite of that, you've got 30 inches, okay? So let's go back up. Let me show you why there can't be two solutions. We saw, let me just erase, or actually let me just box this off. We got an angle measure here of 36 degrees for B, okay, approximately, but let's just work with that. If we look in quadrant 2 and we think about, okay, what angle has a reference angle of 36 degrees? Again, we talked about this earlier. You would take 180 degrees, you would subtract away 36 degrees, and that would give you what? That would give you 144 degrees, okay? So remember, when you did that inverse sine operation, that's only going to give you something in quadrant 1 or 4, okay? We're working with positive values here, so you're always going to get something in quadrant 1. If you want to go into quadrant 2 and get something, okay, something that has the same sine value, in this case 144 degrees, you've got to use that concept of a reference angle. The problem here is that if I say that B could also be equal to this, even if it was approximately, well, we're given that C here is 39, right, degrees. So 144 plus 39 is going to give me 183. Remember, the sum, and let me make that better, the sum of the three angles in a triangle is 180 degrees. So this is not possible. I can't have something that's 144 degrees because I'm going to go over, okay? So you can go ahead and exclude that right away. If you want to prove that to yourself, you can. But again, if you get an angle, in this case it was C, it's 39 degrees, and then the side opposite there, which is 30 inches, is bigger than this B that they're giving you, okay, the side in that position, which is 28 inches, you can go ahead and conclude that you're going to have exactly one triangle, and it's not going to be a right triangle in this case. All right, let's go ahead and take a look at one final scenario with given an acute angle and its side opposite. So you'll see this diagram or this image here is pretty busy. A lot of stuff going on because we're going to have two triangles here. So let me just quickly recap a few of the things that we've already seen. So we saw that if A was basically less than H and H was less than B, that there was no triangle. Right, so there's no triangle in this particular case. But notice that A here is less than B. So this is kind of one of the things where you have to really be careful about what you're doing. Because if you see A is less than B, you could have no triangle, or if we're going to see in a second, you could have two triangles. Then we saw that if A was equal to H, okay, and you could say A or H, whatever you want to do, if A basically is less than B, then you would have a right triangle. And you would just have one, obviously, so one right triangle, okay? Then we saw that if A was greater than or equal to B, you would basically have, and let me not put a comma there, you would basically have one triangle. So one solution, one triangle. Here what you're going to see is that A is greater than H and it's less than B. So when this happens, you're going to have exactly two triangles, okay? So some students don't like to check things this way. They don't like to involve H, and you don't have to, right? You can always use your law of sines. So if you're using the law of sines with this guy, when you try to find the sine of the angle B, it's going to be greater than 1. Okay, so that's how you know you have no triangle. Here, when you try to find the sine of B, it's going to be greater than 0. So you can say it's going to be greater than 0 and less than 1. So this guy is going to give you your two triangles. This guy gives you your no triangle. Okay, so it's important to understand that. When we return here, let me go ahead and write this again. So A is greater than H and less than B. Okay, when we return here, A is going to be the same in each case. It's just how it's drawn. Okay, so you'll see this in your book, this little swing here. So basically the first way, you could draw a triangle this way, okay? So basically you'd have this B sub 1 here, that's your angle B. You have your angle C here, and then down here, I put C sub 1. Most books don't even put a C down there, but basically C sub 1 would be from A to B sub 1 like that. Okay, so the length of the entire thing, that would be your side C. Now, if we swing it this way, okay, and we draw this a different way, the length of A is the same. But now my triangle is going to look like that, okay, basically. And so when you think about C sub 2, now it's just going to be this short piece here, right? So that's my side C. So the angle C changed, okay, from basically here to just a smaller version, okay, and the angle B changes as well. So you're going to see the angle B change, the angle C change, and the side C change when you look at these guys and draw two triangles. Let's go ahead and look at an example here. So we have C is equal to 25 degrees, we have B equals 14 kilometers, and C equals 8 kilometers. So again, when I think about this, I have the angle and its opposite, okay? Don't worry about the letters. It's completely irrelevant, okay? Don't get hung up on that. If I want to find H, again, I'm using that same formula. Take this guy, okay? So this measure here that's not involved in the angle and its opposite, multiply by the sine of the angle you're given. It's all you're doing. So I'm going to take 14 kilometers, multiply it by the sine of 25 degrees, and this is going to be equal to H, okay? And I like my variable to be on the left, so let's just go ahead and put it like this. So H equals this. We'll say H is approximately, let's go ahead and say 5.9 kilometers, okay? So if I think about this, is this guy less than this, okay, and greater than this? Yes, right? If I line this up, I would say 5.9 kilometers is less than 8 kilometers, okay, which is less than 14 kilometers. So I am in a scenario where I have two triangles, okay? That proves that. Now, again, if you just looked at this piece of information and this piece of information, you can only conclude that you either have two triangles or no triangles, okay? So you'd have to use the law of sines to get further into that. So let's go ahead and do that right now so we can start solving this guy. We know we're going to have two, okay? So I'm going to first start by finding my angle B, okay? So how do I do that? Again, I would say that the sine of C, okay, so the sine of 25 degrees, over C, which is 8 kilometers, then basically is equal to the sine of B over, okay, I'll go ahead and say this 14 kilometers here. Now, I know I'm going to multiply both sides by 14 kilometers, so let me slide this down a little bit. And let me do this in a different ink, so I'll say 14 kilometers. We know that this is going to cancel here, and let me just erase it from here. So what would this give us? Well, you get about 0.739. Let's just go ahead and say 6. So I'll say the sine of B is approximately 0.7396, okay? So you want to use your inverse sine function. So I'll say sine inverse of this guy right here, so 0.7396. Again, if you wanted to wrap this guy right here, okay, inside the parentheses when you're doing sine inverse, that's fine too, okay? This is going to be more accurate. Now, if I do this, I'm going to get about 47.7 degrees. So let me erase all this, and I'll say B, okay, B, and I'm going to put sub 1 is about, I put equals, so let me put approximately 47.7 degrees. Okay, so how do I get B sub 2? Remember, we talked about this earlier when we said we would use the concept of a reference angle. All we'd have to do is go into quadrant 2 and say, okay, well, 180 degrees minus this reference angle, 47.7 degrees, would give me 132.3, okay, degrees. So I'll say this is approximately 132.3 degrees, okay? Now I'm going to separate these two. I'm just going to put, maybe a border here or something like that, because we do need to find A, and you can put sub 1, and you want to put lowercase a here, sub 1, right? So this is all for the first triangle, okay? So I'm going to put approximately, and let's just erase this real quick, okay? So another thing here too, and I didn't do this, basically you know this is going to work because again, when you add this, so 132.3 degrees plus this 25 degrees here, this is not going to be greater than 180 degrees. We saw earlier in the lesson we tried to add these guys together. We got 183 degrees, so it was greater than 180 degrees, so it didn't work. Here you have room for another angle because this is going to be 157.3 degrees, okay? So you see here for sure this is going to work and you're going to have two triangles. Okay, so let's erase this. Let me also add down here, I'll put A sub 2, okay? And I'll put lowercase a sub 2 like this. So let's work on this first one here. So if I want a sub 1, all I need to do is go 180 degrees minus 25 degrees minus 47.7 degrees. So this is going to give me, we'd say 107.3 degrees. So this is going to be 107.3 degrees. So let's erase this. And again, we're going to use our law of sines. So I'll go ahead and say that I have 8 kilometers over the sine of 25 degrees. So this is basically c over the sine of c. I'm going to multiply this by, in this case, I would have the sine of 107.3 degrees, okay? This will be equal to a. Again, if I did a over the sine of a, I would end up multiplying both sides by this. That's how I got that, okay? So if you punch this up on a calculator, we'll say this is about 18.1, and this is going to be in terms of kilometers. So we'll say 18.1 kilometers, okay? Let's erase this. And I'll quickly show you the sketch of this guy. So you see here, your angle A is 107.3 degrees. Opposite of that, I've got 18.1 kilometers. Your angle B here is 47.7 degrees. Opposite of that, I've got 14 kilometers. And then your angle C here is 25 degrees. Opposite of that is 8 kilometers, okay? So let's go ahead and look at the other guy. And again, we're going to solve things in a similar way. So now for a sub 2, I'm going to have 180 degrees minus 25 degrees minus now 132.3 degrees. So this equals 22.7 degrees, okay? So let's put 22.7 degrees in like that. And now I just need a sub 2. So again, I'm just going to do the same thing. So I'm going to go 8 kilometers over the sine of 25 degrees times, in this case, I'm going to do the sine of this guy, so 22.7 degrees, okay? And this is going to be equal to a. So let's go ahead and punch this up on a calculator. And you're going to get a is approximately 7.3, and this is in terms of kilometers. So 7.3 kilometers like this. So let's erase this. Again, I've drawn this triangle for us. So if we look at our sketch here, we have our angle A, which is 22.7 degrees. Then opposite of that, we have this 7.3 kilometers. Then we have our angle B, which is 132.3 degrees. Opposite of that, we have our 14 kilometers. Then we have our angle C, which is 25 degrees. Opposite of that, we have our 8 kilometers. So based on the information given, we can see that we can draw 2 different triangles. All right, so let's move on to the final 2 scenarios. These are pretty easy overall. This is when the angle you're given is now an obtuse angle. So basically, you just have 2 situations that deal with this. The first one is, let's say you have some angle A, it's obtuse, and you're given that, and you're given the side opposite of that, so this A here. If A is less than or equal to B, so if A is less than or equal to B, then you'll have 0 triangles. So 0 triangles, or you could say no triangle will exist. Let's look at an example. So here we have A is 125 degrees, B is 18 miles, and A is 14 miles. So again, this A right here is opposite of this angle A here, which is 125 degrees. By rule, a 125 degree angle in a triangle is going to be the largest angle. So therefore, it should be opposite the largest side, and it's not, right? This right here, this 14 miles, okay, is less than this 18 miles, so there's no triangle, right? No triangle exists. And I guess I could clean that up a little bit, so let's make that better. So exists. For the final scenario, we're given some angle A. Again, it's an obtuse angle. And we're given the side opposite, okay? And then we can basically say this side opposite A, in this case, is greater than B. So if A is greater than B here, so if this is greater than this, we'll have exactly 1 triangle. So let's look at an example. So here we have A is 114 degrees, C is 8 feet, and A is 35 feet. So clearly this right here, okay, which is opposite of this right here, is larger than this other guy you've got. So what I would do here is start by finding my angle measure C. So I would do the sine of C is equal to, let's go ahead and say the sine of 114 degrees, so the sine of A, over A itself, which is 35 feet, times it's going to be C, which is 8 feet, okay? So remember, you divide sine of C by 8 feet, and then you multiply both sides by 8 feet, so that's how we set this up. So we know that this is going to cancel with this, and so basically what you'd have is about 0.20, let's say 88, okay? So let's say the sine of C is approximately, I'm going to say 0.2088, okay? So we're going to do the inverse sine. So sine inverse of this guy, 0.2088. this is going to be equal to, let's say about 12.05. So maybe we'll go 12.1. So let's say that C, let's just erase this and put C, is approximately 12.1 degrees. Okay, so let's erase this. All right, so now let's go ahead and find my B. So this is approximately what? Well, I'm just going to do 180 degrees minus 114 degrees minus 12.1 degrees. And this is going to be equal to, let's say 53.9, okay, degrees. So we'll say this is approximately 53.9 degrees. Okay, so we have that. And lastly, we just need this lowercase b, or this side measure. So let's go ahead and put this as approximately what? Again, I'm going to use the information I'm given. So I'm given A and then A here. So I'm going to say, since I want lowercase b, I'll say b is equal to, or put approximately, whatever you want to do. I'm going to say it's going to be this 35 feet, okay? So over, we'll do the sine of 114 degrees. So A over the sine of A. I'm going to multiply this by the sine of this B here. So the sine of 53.9 degrees. Again, we would have had B over the sine of B, so I just multiplied both sides by the sine of B. So that's how I got that set up, okay? So basically what I'm going to have here is, let's say about 31 feet, okay? So let's say approximately 31 feet, okay? All right, so we've solved this triangle. When you get the obtuse situation, it's much easier. When you're dealing with an acute angle and the opposite side, okay, that's when you really have to dig into the details and really think. If you get an obtuse angle and its opposite side, that's pretty easy, right? You're basically going to say, okay, well, I have this one and this one. So is this one right here larger than this one right here that they gave me? If it is, you have one solution. If it's not, meaning they're equal or it's less, then there's no solution, okay, no triangle. So let's go down and look at a little sketch here. So I have angle A is 114 degrees. And again, opposite of that, you have the 35 feet. Angle B is 53.9 degrees. Opposite of that, you have 31 feet. Angle C is 12.1 degrees. Opposite of that, you have 8 feet. In this lesson, we want to talk about the law of cosines with the side angle side and the side side side. And also we'll look at Heron's formula for the area of a triangle. All right, so over the course of the last two lessons, we've been learning about how to solve these oblique triangles using the law of sines. So we saw the easy case with the two angles and the side given, angle side angle or side angle angle, okay? And then we saw the harder case, the ambiguous case of the law of sines, where we had to think about things, right? This is where we had two sides and a non-included angle, so side side angle. Now we're going to look at something that is a little bit different, right? So we're going to have side angle side, so two sides and an included angle, and then also side side side, right? So all three sides, no angles. When these two cases present themselves, we're going to be using the law of cosines now, okay? And we're going to say that a unique triangle can be determined. So we don't have to go through all this stuff that we saw with the ambiguous case of the law of sines. All right, before we get going on some problems, I want to give you some insight in terms of where the law of cosines comes from. I'm not going to go through deriving each one because there's going to be 3 of them, but I'm going to show you one of them and you can get the other ones on your own if you want. Now, some of you might not find this very interesting. Some of you might find it extremely boring. Just skip ahead to the problems if that's you, okay? So the first thing is, you'll notice that we have this triangle here, and it's an oblique triangle, and it's named ABC, okay? Typical. Now, you'll notice that we've put this guy on the coordinate plane, okay, where B basically is at the origin, right? So we have this 0, 0. You'll see for C, you have this A, 0. So where does this come from? Well, opposite of angle A, you have side A, right? Labeled with this lowercase a, right? So this is a length. You can think about this as the line segment BC, okay, right here, okay? Well, basically, this has a length of A, so the x-coordinate there would be A. The y-coordinate would be 0 because you're still on the x-axis, right? So that's where we get the A, 0 there. Okay. Now, up here, this one might be a little bit more confusing, but basically, to get this guy right here and this guy right here, you could start off by calling them x, y, okay? Just start with that generically. Then what you would do is you would take the sine of this angle B, okay? So how would we do that? Remember, this is an obtuse angle here. So what you do is you'd form this right triangle here, okay, like this, and you'd say, okay, the sine of B is going to be equal to what? It's going to be equal to the opposite, which in this case is going to be y, over the hypotenuse, which in this case is c. So y over c, okay? And then let's go ahead and do the cosine of this angle B also. Here you have the adjacent over the hypotenuse, so this is x over c. Okay, so far so good. Now where does this come from, this c times cosine of b and c times sine of b? Well, basically you're just going to solve for y and then solve for x and then plug in each case. Okay, that's all you're doing. So I'm going to multiply here both sides by c. So by c, and basically over here this is going to cancel, this is going to cancel. So y equals c times the sine of b, and here you see c times the sine of b, okay? And here x equals c times the cosine of b, and again, c times the cosine of b. So you're just taking what x is and you're plugging it in there, okay? You're taking what y is or what y is equal to and you're plugging it in there. So that's where all this stuff comes from. So let me erase everything. And now let's talk about a formula to find basically the length of this guy right here. So this would be using the distance formula. We know how to do this from basic algebra. But again, I'm going to call this side here b, right? Lowercase b, because it's opposite of angle b. So how would we do this with the distance formula? We would say what? Let's just write it here real quick. So we have d, the distance between these 2 points on the coordinate plane, is equal to the square root of, you have your x sub 2 minus your x sub 1 quantity squared, plus your y sub 2 minus your y sub 1 quantity squared. Okay, so from here now, what I want to do is I want to replace d with b, because the distance from here to here, it has a name, lowercase b. So let's put that in there, okay? And this is the square root of, again, it doesn't matter how you pick these points. I'm going to label this guy right here as x sub 2, y sub 2, and I'll label this one as x sub 1, y sub 1, just to make it easy. So I'm going to plug in c times cosine of b. So c times the cosine of b, and then basically minus a, this quantity will be squared, and then plus, we're going to do this c times sine of b, so c times sine of b, and then you would do minus 0. I mean, I can put that in there, but it doesn't really do anything, so I'm just going to close this and square it, okay? So let me copy this real quick, and let's paste this here so we have a lot of room to work, okay? So basically, the first thing you would do here, I mean, you could square everything inside first, but I'm just going to square both sides, and I'm going to say b squared is equal to, remove the square root symbol, so you're going to have c times cosine of b minus a, this quantity is squared, plus I'm going to have c times the sine of b, this quantity is squared. Okay, so basically what we want to do here is just expand everything, right? So this one right here, this is just multiplication. So you can just apply your exponent in each case, right? So this will be c squared times sine squared b, okay? But for this one right here, you have 2 terms, right? So you have to expand that or basically FOIL it out, right? In this case, it's a special product formula. So I'm going to have this as c squared, okay, first guy squared, times cosine squared b, okay? So this whole thing is squared, right? C is squared, cosine squared b, right? Because cosine of b is squared, okay? Then you'd have minus 2 times this guy times this guy. So 2 times c times cosine of b, then times a. Okay, if you want to write AC there, we can kind of rearrange that and make that a little bit cleaner. And then after that, you'd have plus the last guy, which is a squared. Okay, so let me put all this together, and let's go ahead and say, don't forget this b out here. So I'm going to say this is b squared, okay, is equal to, this is going to be c squared times the cosine squared of b, and then minus we have 2ac times the cosine of b, and then plus a squared, and then don't forget about this one, so then plus c squared times sine squared b. Okay, so I can erase this at this point. I'm just doing that for kind of side work or scratch work, so I don't want that to confuse you, so I'm just going to get rid of it. Okay, let's move this up here. Now, one thing that might not be completely obvious, but you remember from probably earlier in the course, we saw something where we said sine squared theta plus cosine squared theta equals 1. You have a cosine squared b, and you have a sine squared b here, okay? So if I can get those two together, they're going to be equal to 1, okay? So this is what we're going to do. Let's go ahead and say we have b squared is equal to, I'm going to go c squared times cosine squared b, okay? And then I have this as a term here, this is a term, and then this whole thing is a term. So I'm going to put this over here. So plus c squared times sine squared b, okay? And then what didn't I use? I didn't use this, and I didn't use this. So let me put those after. So let me go plus a squared, and then minus 2ac times the cosine of b, okay? So some of you will see where I'm going with this. Others will be lost, and that's fine. I'll show you right now. Basically, what I'm going to do here is factor out the c squared, okay? So I'm going to have the b squared is equal to, we'll have this c squared out here, and then inside you'll have cosine squared b, plus sine squared b. Okay, so that's taken care of. And then plus you have your a squared minus 2ac times the cosine of b. Okay, so this right here we know is equal to 1, right, by definition. So you can erase this and just put a 1 in there, or just erase it altogether because you don't need it anymore. So let's move this down here. Okay, slide this down here, and basically you're done. So this is the law of cosine. So b squared is equal to c squared, then plus a squared, then minus 2ac multiplied by the cosine of b. Now, in your book, it's going to be rearranged. They'll put a squared here first, okay? And they'll put c squared here in the second position. But again, because this is just addition here, it wouldn't matter, okay? But this is how it's going to be listed in your book, so I want to be consistent. So where would this be useful? Let's go back up. I have things in terms of b squared, right? So if I knew my side A and my side C and my angle here B, okay, my included angle, well, then I could find the length of this guy B here, or the distance between these 2 points, using that formula. Okay. Now, additionally, we have 2 other forms, and I'm not going to derive this. Obviously, it would take forever, but you can do a similar process. So I'm going to do a squared is equal to, in this particular case, you're going to have b and c now. So b squared plus c squared, and then minus, you'll have 2 times b times c times the cosine of a. Okay, and I think you see the pattern, right? So basically, you think about the side that you are solving for, it's the other 2 sides that you're going to need, right? So b and c in this case, you get b and c here, and it's the cosine of the angle A opposite of this side A. And then the last one, you probably guessed it, so c squared is equal to, you're going to have a and b now, so a squared plus b squared minus 2 times ab times the cosine of, again, opposite of c would be big C, cosine of capital letter C, however you want to think about that. So to give a little summary of this little law of cosines, we're going to say that the square of a side of a triangle is equal to the sum of the squares of the other 2 sides. Then you could go less twice the product of the 2 sides and the cosine of the included angle. Okay, so this is a very easy pattern to memorize. Just go ahead and write it down in your notes. We're going to use it today. Okay, let's look at some examples here. I'm going to do 2 with side angle side and then 2 with the side side side. And then we'll look at some Heron's formula area problems. So the first thing you'll notice here is you have side angle side, right? So I have side B is 21 inches. I have angle C is 100 degrees. And I have side A is 27 inches. So let's go ahead and write this down. So we had B was equal to 21 inches, okay? We had A was equal to, it was 27 inches. And then we had angle C was 100 degrees, okay? So with this guy, again, what you're trying to do in this particular case, you're trying to figure out, when you start, what is the missing side, right? So what is this C over here? What is this? So equals what? So let's come back. Okay, we're just going to plug into it. It's very simple. So C squared is equal to, hopefully you didn't forget this, so it's the 2 other guys. So it would be A squared plus B squared, okay? Then minus, it's 2 times this guy times this guy. So 2 times A times B, and then times the cosine of this angle here that you have. So the cosine of C, okay? Once you work with this a few times, it becomes very, very easy to remember it. And you're just going to plug in and basically hit this on a calculator and you're done, okay? So let me show you what you're going to plug in here and we'll approximate it together. You know that you want C by itself, okay? And C is going to be positive, right? So we don't need to consider plus or minus square root. So I'm just going to say C is equal to the square root of all of this, okay? So let me grab that, and I meant to just grab this part, and it doesn't seem to be doing that, so let me write it. A squared plus B squared minus 2AB, and then times the cosine of C. Okay, so C is equal to the square root of, let's plug in here. So for A, I'm going to plug in 27, okay? You can put the units in if you want or not. In the end, it's going to come out to just be inches, so I'm just going to leave them off, okay? Then plus, for your B, it's going to be, and I forgot to square this, for your B, it's going to be 21, so 21 squared, and then minus 2 times your 27 times your 21, and then times your cosine of 100, okay, degrees. Now, you're just going to punch this into a calculator, and I get about 36.97, and I'm going to do 37, okay? So I'm going to say my side C, okay, this is a lowercase c, is equal to 37, and then the units are inches, okay? All right, so let's erase this. And let's put here that C is approximately 37 inches. Now we need to find our 2 missing angles here, okay? And let's talk for a minute about using the law of sines or using the law of cosines. If you go back and you think about it, you can always, in any of these formulas, you can solve for this guy, okay? And you can end up using your inverse cosine function to solve, okay? So that's fine. If you want to use the law of sines, you have to be very, very careful. Why? Remember, if you have an obtuse angle and a triangle, you can only have one of them, okay? And it's going to be opposite the largest side. If we go back here, remember, assuming the triangle has sides that are all of different lengths, the smallest angle is opposite the shortest side, the middle valued angle is opposite the intermediate side, and the largest angle is opposite the largest side. Okay, so what am I getting at here? Well, basically what's going to happen is, in this particular case, you have an obtuse angle already, okay? So it is opposite of the largest side, and we can clearly see that. But let's say that you didn't have an obtuse angle. Let's say you had an angle that was like 30 degrees, for example. Well, when you go to find your other missing angles, if you're using the law of sines, you might run into a problem, okay? Because when you think about the inverse sine function, you can't get an obtuse angle out of that, okay? You can't. You can only get something in terms of from quadrant 1 between 0 and 90 degrees, okay? That's all you can do. So if you had something larger than 90 degrees, you would get the wrong answer, right? So for example, if the angle measure should be 110 degrees, if you plug in the inverse sine function there, you would end up with 70 degrees, okay? That's just how it works. So what we do to fix this is we find the smaller of the two remaining angles using the law of sines, okay? Because if I find the smaller one, then it's not possible for it to be the obtuse angle because, again, a triangle can only have one obtuse angle. So if I'm finding the smaller one, it can't be that one. So I'm good to go to use the law of sines, okay? So let's go ahead and find the angle measure B, right? Because it's opposite the smaller side, right? This one's 21, this one's 27. Okay, so let's go back and let's go ahead and say that we have the sine of, in this case, C, which is 100 degrees, okay, over C, which is 37 inches, is equal to the sine of B over B is 21 inches, okay? So we already know how this is going to work. We're basically going to multiply both sides by 21 inches. So we'll say that the sine of B is equal to, we'll have 21 inches times, you're going to have the sine of 100 degrees. This is all over your 37 inches, okay? And you can go ahead and cancel the units inches out if you want visibly. Just punch this into your calculator, and you're going to find that the sine of B is approximately, let's just say it's 0.55, I'll just say 89, okay? So if you use your inverse sine function on this, I'll say sine inverse of this 0.5589. This is approximately, we'll say 33.98. So I'll round that to 34. So I'll say this is about 34 degrees. Okay, so that would be your measure for angle B. So let's erase all this. And I'll say that B is approximately 34 degrees. And then to find A, all you have to do is subtract, right? So you're going to do 180 degrees. Basically minus your 100 degrees. Okay, so that would be 80 degrees. And then minus your 34 degrees, which would give me 46 degrees, okay? So A is approximately 46 degrees, okay? So we've solved this guy. Let's go back up, and I'll just say this is 34 degrees, and I'll say this is 46 degrees. All right, let's look at another example with side angle side. I'll go faster on this one. So basically here you have a side C that's 16 centimeters. You have an angle B that's 89 degrees, and you have a side A that's 28 centimeters. So let's say C is 16 centimeters. Let's say that angle B, sorry, I was writing A, but angle B is 89 degrees. And then let's say that side A is going to be 28 centimeters, okay? So again, the first thing I want to do is find the missing side, right? So we're going to say B is equal to what? So again, just use your law of cosines, very easy. So we're going to say B squared. So B squared is equal to, again, which ones are not involved? So it's going to be A and C. So A squared plus C squared, and then minus 2 times A times C times the cosine of this angle here, which is B, okay? So we're just going to plug in. So let's just go ahead and say this is B is equal to the square root of, I'm going to plug in for A, that's going to be 28. And forget about the units, you don't really need them because it's going to end up just being centimeters. So then plus for the C, it's going to be 16. And then for the minus 2 times, again, it's going to be, and this needs to be squared, 2 times for this is going to be 28, and then times 16, and then times the cosine of, in this case, it's 89 degrees, okay? Let's punch this into a calculator. So I get about 32, let's just call it that. So I'll say it's about 32 centimeters. So we'll come here and we'll say that our side B is approximately 32 centimeters. And again, if we go back up here, we can just label this. I'll say this is approximately 32 centimeters. And again, you just want to take, out of these two sides here, you want to take the smaller side, okay, and then go opposite, and you want to find that angle measure. So I'm looking for angle C here because, again, it's not going to be obtuse. It's not possible, so I can use my law of sines. If you want to use the law of cosines, you can do that as well. It's up to you, okay? So let's go back, and let's figure out angle C. So I'm just going to say the sine of C is equal to, so I'm going to write 16 centimeters here. And again, you can leave the units off because you know you're going to end up canceling them out, but I'll just show it here. And then times, it's going to be basically the sine of 89 degrees, which is basically B, okay, over B, which is, in this case, 32 centimeters, okay? I'm going to visibly cancel these units, punch this into a calculator, and you'll see that the sine of C is approximately, I would say, 0.4999, let's just call it that. But if you wanted to make this a little quicker, you just take this whole thing, plug it into your calculator for the inverse sine function, and you'll have C, okay? I'm just doing this in 2 steps to make it a little bit easier to comprehend. So 0.4999, and then I'll say sine inverse of this guy, 0.4999 would be approximately, let's say it's about 30 degrees. Okay, so that would be for C. Okay, so let's erase this. So we'll say C is about 30 degrees. Okay, and then again, if you want to find A, you're going to do 180 degrees minus 89 degrees minus 30 degrees, which is 61 degrees. So I'll say that A is approximately, okay, I'll say 61 degrees. So we'll say this is about 61 degrees, and we'll say this one is about 30 degrees. All right, let's change things up just a little bit and look at the case where we have the side. So we have all 3 sides, and to solve the triangle, you need to find the 3 missing angles. So in this particular case, let me just read this off. We have our side A, which is going to be 17 miles. Let me make this equal sign a little bit better, okay? And then we have our side B, which is going to be 15 miles. And then we have our side C, lastly, which is going to be 28 miles, okay? So based on the information about a triangle that we know that this angle C here would be the largest angle, okay? Because it's opposite of this largest side, okay? So when you have all 3 sides, you're going to first find the largest angle using your law of cosines, okay? So let me grab this real quick. Let me cut it away. Let's come to a fresh sheet so we have a lot of room to work, okay? And I'm going to be focusing on finding our C. So what is this guy? What is the measure? So let's turn back to our law of cosines, and I'm going to use the one with the cosine of C involved. So in other words, let me just erase this real quick so I have some room. Let me box this off. I'm going to say, or actually I can actually do this up here. I'm going to say that C squared is equal to, remember, take the other ones that aren't involved. So you're going to have A squared plus your B squared and minus 2 times A times B, okay, times the cosine of C. So the idea here is that you're going to isolate the cosine of C, okay? So it's going to be equal to something, okay? You're going to be able to plug in for A, B, and C here, okay? And so then you can use your inverse cosine function and find out what C is approximately. Now, when you talk about the law of sines, again, with the inverse sine function, you run into problems because the inverse sine function is not going to be able to give you something in quadrant 2, right? So you're not going to be able to get an obtuse angle out of that. With the inverse cosine function, you can, right? It returns something from 0 to pi in terms of radians or from 0 to 180 degrees. So if you get a negative cosine value, you know you're in quadrant 2 and you have an obtuse angle. If you get a positive cosine value, okay, you're in quadrant 1, and so you have an acute angle, okay? Let's quickly solve this guy for the cosine of C. In the next example, I'll just give you the formula, but I just want you to see where this comes from in your book. So the first thing I would do is I would subtract A squared, and I would subtract B squared away from each side, okay? So minus A squared, and then minus B squared. So it's going to cancel over here. Let me write this down here. I'll say we have C squared minus A squared minus B squared is equal to the negative of 2AB times the cosine of C, okay? This is multiplication here, so what I'm going to do, to isolate this, I'm going to divide both sides by negative 2AB, okay? So divide both sides by negative 2AB. Let me erase this from up here so we can write this formula up here. This is, of course, going to cancel, so that's gone. So you'll have the cosine of C is equal to, you'll have your C squared minus A squared minus B squared over the negative of 2AB. Now, because this is a fraction, I can keep my negative down here, or I can get rid of it, and I can bring it up to the top like this, right? So I could distribute it to each part. So I could say this is negative c squared plus a squared plus b squared, okay, like this. And then I'm going to rearrange it. So I'm going to say, and this is how it's going to be in your book, so that's why I'm doing this. So the cosine of c is equal to, I'll say this is a squared plus b squared minus c squared all over 2ab. And I know it takes a while to get these things, and in tutorials we're used to just being given the formula, but I want you to see where things are coming from in your book so you're not always just getting things handed to you, okay? So let me grab this up here, and basically now I'm just going to plug in, okay? And to make this quicker, if you wanted to, you could just do the inverse cosine of whatever this is to give you c, right? So you could say c is equal to the cosine inverse of, so I'm just going to plug in for a, b, and c here. You can leave your units off. You know they're going to cancel. So a is going to be 17, so that's squared, plus b is going to be 15, that's squared, minus c is going to be 28, that's squared, all over 2 times, you're going to have your 17, and then times your 15, okay? So just punch this into a calculator, use your cosine inverse function, and let's say that's about 122 degrees, okay, if we round to the nearest tenth. So I'll say here that c is approximately 122 degrees, okay? And if you look at this value right here, you'll notice that this guy is negative, okay? So if the cosine value is negative, you're going to get an obtuse angle, right? Because you're getting something in quadrant 2. If this guy ends up being positive, you're going to be in quadrant 1, and you're going to have an acute angle, okay? But you see how you avoid that problem versus when you're working with the law of sines. Right there, you really have to be careful about what you're doing. So now that we have the largest angle, when I think about the angle A or the angle B, they have to be acute angles, right? If you always find the first angle as the largest angle, then you don't have to worry about the next 2 angles. You can just use the law of sines, okay? So let me get rid of this, and let's just use our law of sines here real quick. So I'm going to say, in each case, that I have the sine of, in this case, 122 degrees, over whatever c is, which is 28 miles. Again, you can write the units if you want. It's going to end up canceling. So I'm going to multiply this by, let's just start with a. We'll say it's approximately what? So let me go, the sine of a is equal to this. So I'm going to multiply this by what I would have divided by here, which is 17 miles. Okay, so you can see that this is going to cancel here. Then to make this a little bit quicker, let's just go ahead and say a is going to be equal to, we're going to do our inverse sine function. So sine inverse of this whole thing, so the sine of 122 degrees over 28, then times 17, okay, like this. So if we punch that into a calculator, you're going to get about 31 degrees. So let's say A is about 31 degrees, okay? And then once you have those two, again, you could just use the angle sum property of a triangle. So again, 180 degrees is the sum of all the angles. And make that 0 a little bit better. Then minus, you've got this one as 122 degrees. Then minus, you got this one as 31 degrees. You can just say this is 27 degrees, okay? So this is about 27 degrees. So let's go back up, and I'll say C is 122 degrees. Again, this is an approximation. A is about 31 degrees, and B is about 27 degrees. Okay, let's look at one more example. I'll go a little bit quicker through this one. So we'll say A is 13 feet, okay? And then you could say B is going to be 29 feet. And then C is going to be 21 feet. Okay, so let me grab this and let's paste this in. Again, you're going to work with your largest angle first. So look for your largest side. So that's going to be here, right? So we're going to be looking for B. So I'm just going to give you this formula. Again, if you wrote out the B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of B, okay? And you solved it for the cosine of B, you're going to end up with the cosine of B is equal to, we'll say A squared plus C squared minus B squared all over your 2AC. Okay, so let's get rid of this. And again, if you really wanted to take this forward, you could say that B is equal to the cosine inverse of, you can just grab this right here. So A squared plus C squared minus B squared over 2AC. Okay, so you can just plug in like this and basically find out what B is approximately. All right, so let's plug in. For A, we have 13 feet. So we have, let me change colors here. We have 13 feet. I'm just going to put 13. Forget about the units. So for C, I'm going to put 21. So put 21. And then for B, I'm going to put 29. So let's put 29 there. And then 2 times A times C. So A is 13. And C is going to be 21. Okay, so let's punch this into the calculator, and I get about 115 degrees. So B is approximately 115 degrees, okay? Let's erase this. And again, I've got my obtuse angle, okay? So once I have my obtuse angle, the other ones are going to be acute for sure, okay? So I don't have to worry about the law of sines, right? It's not going to give me an error if I use that now. All right, so let's solve for A. So we have the sine of A is equal to, we go A, which is basically 13 feet, times, let me make that 3 a little bit better, times, we're going to go the sine of B, so the sine of 115 degrees, and this is all over B itself, which is 29 feet. Now, we're going to end up taking the inverse of this, so you might as well say that A is equal to, let me slide this down, A is equal to the inverse sine of this guy right here, okay? So let's punch this into the calculator, and let me visibly cancel these units, and you'll get about 24 degrees, so I'll say A is approximately 24 degrees. So let's erase this. And then again, for C, all you have to do is do 180 degrees minus 115 degrees minus 24 degrees, and that's going to give me 41 degrees. Okay, so this is about 41 degrees. So let's go back up, and we'll say B is about 115 degrees, A is about 24 degrees, and C is about 41 degrees. All right, let's talk about this Heron's formula and how to find the area of a triangle given the three sides, so side, side, side. You can also use this with side angle side, okay, and I'll show you that in a moment, but it's much slower than the formula we saw with the law of sines, okay? So with this guy right here, I'm given that basically, let's say side A is going to be, so A is 10.7 meters, then let's do side B, that's going to be 9 meters, and then side C is 10, let me put the C there, so C is going to be 10.5 meters, okay? So let me grab this, cut this away, bring this over here. Let me paste this in here, okay? Let me give you a little formula. Okay, so for Heron's formula, basically the first thing is you're going to find the perimeter of the triangle and divide it by 2, okay? In your book, you're going to see this called S. So S is equal to, you could say 1/2 times, you sum the sides. So A plus B plus C, okay? You know how to get the perimeter of a triangle. So in this particular case, S would be equal to, we'd have 1/2 times, your A is 10.7. I'm going to leave the units off for now. So 10.7 plus 9 plus 10.5 is 30.2. Okay, so this would be 30.2. You can put meters in there if you want. It's up to you. And then basically I would divide this by 2. So you could say S is 15.1. Okay, so let's say 15.1. Again, if you want to put meters there, you can. In the end, you know with area, it's whatever units you have squared. Okay, so if you want to work with that, that's fine. So then from here, what you're going to do is you're going to plug into this kind of long formula. So the area is equal to the square root of, you're going to take this S and you're going to multiply it by your S minus your A, then your S minus your B, okay, then your S minus your C, okay? Very easy formula to remember. So basically if I plug in here, I would say the area is equal to, and again, I'm going to leave the units off to make this shorter. You would end up with meters, 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 meters. So meters to the 4th power. When you take the square root of the 4th power, you get the 2nd power, or squared, which we know from an area formula, that's what you get, okay? So you're going to end up with meters squared, so I'm just going to tell you that in advance, okay? So basically for S, this is going to be 15.1. Then times, you would do 15.1 minus 10.7, which is 4.4, okay? Then S, which is 15.1 minus B, which is 9. So that's going to give me 6.1, okay? And then S, which is 15.1 minus your C, which is 10.5, which would give me 4.6. Now, of course, you don't have to set it up this way. You can just punch it straight into the calculator. I just wanted to give you a little insight into what's happening. So I'm just going to crank this out in the calculator and see what I get. So I get about, let's say 43.2 if I round it to the nearest 10th for the area. Okay, so I'll say the area of that triangle, we'll say is approximately, I'll go 43.2. Okay, let me slide this down. Don't forget your units. You want to put your meters squared, because again, if you had meters here, 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 and here, okay, you would have had meters to the 4th power. When you take the square root of that, you would have got meters squared. Okay, so that's where that comes from. All right, let's look at another example. So this is side angle side here. So basically with this one, it's going to be faster using that area formula with sine. So with that one, let me just copy this down. So C, let's say C is 5 meters. We'll say A is 71 degrees. And we'll say B is going to be 7 meters. Let me copy this real quick. And let me come down here. And let me paste this in here. Okay. So you remember that formula where we said the area. So the area is equal to 1/2 times, you'll say, in this particular case, I have B and C. So BC and then times the sine of the angle that's included, so 71 degrees. So what is B, what is C? One is 7 meters and one is 5 meters. So let's just throw this in here. So 7 meters and then 5 meters. And I can't fit this in here, so let me drag this down a little bit. So 7 meters and then 5. Let me slide this down right there so I can make that fit, meters. So basically you'd have what? You'd have 35 meters squared over 2. Let me write that like that. So 35 meters squared over 2 times the sine of 71 degrees. Let's punch that into a calculator. I'll say it's about 16.5 meters squared. So let's say the area. So the area is about 16.5 meters squared. Okay, so we already know how to do it that way. The way I'm about to show you is going to be much slower, but we're going to get a lot of practice. The first thing is I would want to find this missing side lowercase a. Okay, so how do I do that? So a squared is equal to, what's not involved here? You have b squared and then plus your c squared and then minus your 2 times b times c and then times your cosine of the a. Okay, so let's go ahead and say a is equal to the square root of all this stuff. So b squared is what? It's 7. Forget about the units. We'll say it's 7 squared plus c squared is 5 squared minus 2 times, you're going to have 5 times 7, okay? And then let me make that a little bit better because my handwriting is getting pretty sloppy. And then times the cosine of this 71 degrees. So let's punch this into a calculator. So I get about 7.2, okay? But how you round here is really going to matter because you're going to end up rounding twice. So I'm going to put 7.2, but that's going to really throw the answer off. So let me put A is about 7.2 meters, okay? So let's get rid of all this. And then let's quickly use our Heron's formula. So we would say, first and foremost, that S is equal to, we would sum the sides. So you'd have 5 plus 7 plus 7.2, which is 19.2, divided by 2 is 9.6. And this is going to be in terms of meters, so you can write that. And then basically with your area formula, so your area, it's going to be equal to, again, the square root of, you take this guy right here. Again, forget the units. So we're going to put 9.6 times, you would do 9.6 minus, in this case, 7.2, which is 2.4. And then you'd have times, you do 9.6 minus your 7, which is going to be 2.6. And then you would do 9.6 minus your 5, which would be 4.6. Punch this into the calculator, and you'll get your area is approximately, I would say about 16.6 meters squared here. So you can see there is a difference based on the rounding. Okay, here with the better formula, we got 16.5 meters squared. Here, because we ended up rounding twice, we got 16.6 meters squared. So again, if you get side angle side, you want to use that first formula. I'm just showing you can do it this way if you get this on a test. Sometimes they want you to do that just to get some extra practice.